Dear students, welcome to the next video lecture of Circuits and Networks. I am Deepak Videv, Assistant Professor, Department of Electrical and Electronics Engineering with the Academy of Science and Technology. In today's video, I will be explaining two methods, that is node analysis and supernode analysis. These methods are used for analyzing electrical circuits. And in node analysis, you have to follow these steps to analyze a circuit. So our first step is to identify all the nodes in the circuits and take the node with maximum branches as the reference node. And what is a node? A node is a point of connection or point at which more than two branches meets in a circuit. So there should be at least three branches in a node. Actually, it is known as a principal node of the circuit. So you have to identify such nodes, that is principal nodes. And the node with maximum branches is taken as the reference nodes and its voltage is assumed as 0 volt. That is the first step. And the second step is to assume suitable direction for branch currents. So in a circuit, there will be so many branches. In each branches, if the currents are unknown, then you have to assume currents with suitable direction. You can take any direction. That is the second step. Then apply KCL at each node except the reference node. That is the third step. Then express the branch currents that are unknown in terms of the node voltages. So already in the step 2, we have assumed the current through different branches. If the currents are unknown, you have to express that currents in terms of node voltages. That is the steps 4. Next step is to rewrite the equation from step 3 using node voltages. So in step 3, we write the KCL equation in terms of currents and you have to express that currents in terms of node voltages in step 4. So step 3 current equation is expressed in terms of voltages that are derived in the step 4 and it is written in the step 5. So in the last step, you have to solve the resulting set of equations for node voltages. Thus, in the nodal analysis, we get the node voltages. From the node voltages, you can find the branch currents by using the equations in the steps 3. I will explain these steps in detail by using an example. So this is an example. Here we have to find the current through 5 ohm resistance. So in this example, there is a current source. This example can be solved using mesh analysis. Actually, you have to use the super mesh technique since there is a current source in the third mesh. This example here we will be solving using node analysis method. So the first step is to identify the nodes. Here there are 3 nodes. What are they? Here there is a node where 3 branches are meeting and another node is here. There is also 3 branches are there in that node and there is one more node at the bottom where 4 branches are meeting at that node. So we identified the nodes. This node in the bottom where the maximum number of branches, that is 4 branches are meeting, is taken as the reference node. So step 1 is 3 nodes are identified and the bottom node having 4 branches are taken as the reference nodes. If all the nodes have the same number of branches meeting at that node, then you can select any node as a reference node. Usually the node with maximum branches are taken as the reference node. And we will assign the node voltages Here for the first node 1, that is here, we assume the voltage as V1, and in the node 2 we assume the node voltage as V2, and for the reference node the voltage is assumed as Vg, that is ground potential, that is 0 volt. Okay. Next step is to identify, write the branch currents, and in this figure you can see that at different branches we assume the branch currents. You can assume the direction as your wish. So I have marked the branch currents as in the figure. So I1 is the current flowing through the 2 ohm resistance, that is this one, and then I2 is the current flowing through 3 ohm resistance, this 3 ohm resistance, and I4 is flowing through 5 ohm resistance. In this branch the current is known, that is 2 ampere, so you don't need to write the current in that branch. If the current is known, you don't have to mark the current through that branch. So first step is to identify the nodes, and the second step is to branch currents. Mark the branch current according to your wish. Then step 3, apply KCL at each node except the reference node. So for the node 1, that is here, the node 1 is here. In this node the I1 is entering current, and I2 and I3 are leaving the node. So KCL equation will be I1 is equal to I2 plus I3. Similarly, in the node 2, that is here, the KCL equation will be I3 is the entering current, I4 is leaving, and the 2 ampere is entering. So I3 plus 2 will be equal to I4. That will be the KCL equation for node 2. So as in steps 3, the KCL equations are written at the points at the node 1 and node 2. Then we have to express each of these currents I1, I2, I3, I4 in terms of node voltages. How to express that? Let us look back. Here I1 is the current flowing through 2 ohm resistance. So you have to look into the 2 ohm resistance. Here for 2 ohm resistance, at this point the voltage is 2 volt, and here the voltage is V1. So at one end of the voltage, one end of the 2 ohm resistance, voltage is 2 volt, and another end the voltage is V1. So current through 2 ohm resistance can be expressed using Ohm's law. What is Ohm's law? Current through a resistance will be equal to voltage across that resistance by the value of resistance. So I1 is flowing from this end to this end. So I1 can be expressed as the voltage at this end minus voltage at this end divided by the resistance, that is I1 is equal to 2 minus V1 by 2 ohm. Similarly, you can express the currents at each branches. So we can express what is I2. I2 is flowing from node 1 to the ground. So I2 can be expressed as voltage at this node, that is V1, minus voltage at the ground, that is 0, divided by the resistance, that is 3. So I2 is equal to V1 minus 0 by 3, or V1 by 3. Next, how to express the current I3? I3 is flowing from node 1 to node 2. At node 1 the voltage is V1, and at node 2 the voltage is V2. So I3 is equal to V1 minus V2 by 1. If the current direction is opposite to that in the figure, then I3 will be V2 minus V1 by 1 ohm. So you have to thoroughly investigate the circuit when expressing the current in terms of voltage. Next one is I4. I4 is the current through 5 ohm resistance and it is flowing from node 2 to the ground. So I4 is equal to voltage at node 2, that is V2 minus ground voltage 0 by 5. V2 by 5 will be the I4. Thus, we expressed the currents I1, I2, I3 and I4 are in terms of node voltages. The next step is to write the KCL steps 3 equations using the equations in the step 4. So you have to substitute I1 by using equation 11 and I2 by using equation 12 and I3 by using equation 13 and I4 by using equation 14 in the KCL equation. Thus, the KCL equations, that is equation 9 and 10, becomes equation 15 and 16. That is the last step. And you have to separate the variables. That is, you have to separate the terms containing V1 to left side and V2 the left side, and the constant term should be taken into the right side. So this equation 15 and 16 should be separated and you have to solve those equations to get V1 and V2. So in these two equations there are two variables V1 and V2 and we have these two equations, so you can solve it using calculator and you can find the value of V1 and V2. That is the node analysis method. So I will again explain it. The first step is to identify all the nodes and the take node with maximum branches as the reference nodes, and the voltage at the reference node is taken as 0 volt. Then assume suitable direction for the branch currents. You can assume whatever direction you think, or you decide about the direction. You can decide which direction is suitable for any branches. And apply KCL at each node except the reference node. You have to apply Kirchhoff Current Law and express each branch currents and using unknown voltages, and rewrite equation from step 3 using node voltages and solve resulting set of equation for node voltages. These are the steps to be followed in the node analysis method. Okay. So now let us find the let us have a next example, that is example 2. Here you have to find the currents applied by the 5 volt battery. That is the question. You can solve this equation using super mesh technique, because in the first mesh there is no current source, second mesh also there is no current source, but in the third mesh there is a current source. So this circuit can be solved using super mesh techniques, and it can also be solved using Supernode method. What is the reason? Here between V1 and V2 there is a voltage source, and here there is a voltage source, and there is no resistance in between this V1 and V2. So if a voltage source is connected directly between two nodes, then you have to apply the Supernode technique. The steps for analyzing a circuit by using Supernode analysis is similar to that of node analysis method or nodal analysis method. So the first step is to identify the nodes in the circuit. So this circuit is similar to that of previous one. Here also you can identify 3 nodes. What are the first node is here, node 1 and node 2, and there is a larger node that is taken as, that is ground node. So we will assume the voltage at this ground node as 0. Okay, so we identified the nodes and the node voltages are assigned as V1 and V2. Okay, Then okay, then you have to assume the currents through different branches. So as in the previous case, I assumed the current through 2 ohm resistance as I1 and the current through 3 ohm resistance as I2 and the current through 5 ohm resistance as I3 as in the figure. So nodes are identified and the branch currents are assumed suitably. These steps are identical. Now we have to express the currents in terms of voltages. So how to express I1? I1 is the current through 2 ohm resistance and at one end the voltage is 2 volt and another end it is the V1. So I1 is equal to 2 minus V1 by 2. Also I2 is V1 minus 0 by 3 and I3 is V2 minus 0 by 5. So you can express the currents in terms of voltage. Here in this branch the current is known, so you don't have to assume the current through that branch. Okay, so each currents are expressed in terms of voltages. Next we have to apply KCL. Here is the difference. Here we cannot apply KCL, Kirchhoff Current Law, at the node 1 or node 2 individually because here the current flowing from 5 volt is unknown quantity and we cannot predict that current. That's why we cannot apply Kirchhoff current law at node 1 or node 2 individually. So what we do in supernode method is that we will assume that this node 1 and node 2 together as a supernode. We assume that it is a single node and we will apply Kirchhoff current law at this supernode and you will get a equation. So what is that equation? So if we consider this full part as a single node, I1 is the current that is flowing into the supernode, I2 is leaving from the supernode, I3 is also leaving and 2 ampere is flowing into the supernode. So at this supernode, Kirchhoff current law states that incoming current is equal to outgoing current, that is I1 plus 2 will be equal to I2 plus I3. I1 and 2 ampere are incoming current and I2 and I3 are outgoing current. So I1 plus I2 is equal to I2 plus I3. That will be the KCL equation at the supernode. So you will get an equation. And also from the supernode itself you will get a voltage relation. What is that? If a battery is connected like this, it means that voltage at this point is 5 volt higher than the voltage at this point, which means that V1 is 5 volt higher than V2, or V1 is equal to 5 plus V2, or V1 minus V2 is equal to 5 volt. That is the second equation. So in supernode method, we will take the nodes that are directly connected through a voltage source as a supernode, and we will apply Kirchhoff current law at that supernode and you will get a set of equation, and you will get another set of equation when you look into the supernode. That will be a voltage equation. The first one is a current equation and the second one is a voltage equation. Okay, so applying KCL at the supernode, you will get I1 plus 2 is equal to I2 plus I3, and you have to express I1 in terms of voltage we already written in the previous slide. So I1 plus 2 is equal to I2 plus I3. I1 can be written as 2 minus V1 by 2 and I2 can be written as V1 by 3 and V2 by 5. Also from the super node, V1 minus V2 is equal to 5 volt. Now in the equation 20 and 21 there are only two variables, that is V1 and V2. So by solving equation 20 and 21, you can find value of V1 and V2. After getting V1 and V2, you can find any current. Here in this problem, we have to find the current supplied by the 5 volt battery. If you get I1 and I2, what is I1? I1 is 2 minus V1 by 2 and I2 is V1 by 3. So if you get V1, you will get I1 and I2. Once I1 and I2 are obtained, you can find the current supplied by the battery, that is current supplied by the battery by applying KCL at the node 1. Once you get I1 and I2. So this method is the node analysis, super node analysis. This method is used when two nodes in a circuit are directly connected through a battery. There should not be any resistance in between the two nodes. They should be connected between a battery. If that is the case, you have to apply this technique. Okay, that is super node analysis. Thus, in the today's video, we discussed about node analysis and supernode analysis. I hope all of you understood these topics. Thank you.